In today's video, we're going to go over how to solve some optimization problems for calculus. So for the first problem, we're going to go over a rectangle with a fixed perimeter. So let's say we have a rectangle that has a perimeter of 40 meters. What dimensions would maximize its area? So firstly, we're going to let x equal length, and then we're going to let y equal width. Now from here, our constraint is going to be 2x plus 2y is equal to 40. Now, if we isolate for y, we're going to have y equal to 20 minus x. Now from here, we can use our area equation. So area is equal to the length times the width, so xy. And now that is going to be equal to x times 20 minus x, which is equal to 20x minus x squared. Now from here we can take the derivative of 20x minus x squared. So a prime is simply equal to 20 minus 2x and then we can set a prime to 0. So 0 is equal to 20 minus 2x. And when we isolate for x, we'll get 2x is equal to 20 and x is equal to 10. And so since x is equal to 10, our y is also going to be equal to 10 because it's simply 2x plus 2y. So had we done the complete opposite but solving for y, had we done the complete opposite, we would have gotten y is equal to 10 as well. So our max area when the rectangle is a square is going to be 10 meters by 10 meters. Let's try another problem. So let's say you had a square piece of cardboard, 20 centimeters on each side, and it is made into an open box by cutting out equal squares from each corner and folding up the sides. Find the cut size which maximizes the volume. So here, we're going to let the cut size be equal to x. And then we're going to write out our box dimensions. So 20 minus 2x is our length. And then our width is going to be 20 minus 2x. And then our height is simply going to be h, or we can say our height is x. Our height is going to be equal to x. So from here, what is our volume? So our volume is going to be equal to x times 20 minus 2x all squared. So then we can take our derivative of that. So v prime is going to be equal to 20 minus 2x squared minus 4x times 20 minus 2x. And then from here we can simplify this. So our v prime is going to be equal to 20 minus 2x squared Sorry, I messed that up. When we simplify this, our v prime is going to be, when we multiply it all through, it'll be 400 minus 80x plus 4x squared minus 80x plus 8x squared. And if we simplify that, and we add the like terms, we're going to get 400 minus 160x plus 12x squared. So when we set v prime, we're going to get 0.12 x squared minus 160x plus 400 is going to be equal to 0. And then when we solve for x, we're going to get approximately, and you can run this into a calculator, we're going to get approximately 20 over 3, or if you get the exact value, it'll be about 6.67 centimeters. So our max volume when we'll get max volume when the cuts are about 6.67 centimeters. So that's optimization. So whether it's calculating max area, volume, or minimizing distances and cost, the steps are the same. We define the variables, we reduce to one equation, we differentiate, and then we solve. I hope this video helped. Thank you.